Hello, you're welcome to today's class. Today I will be taking you on mathematics once more. As you know, this is Sigma Tech Consult Limited, and today we'll learn a very interesting topic in mathematics. That topic is algebra, just as you can see displayed on your screen there. So I know this algebra will look at HCF, we'll look at LCM, we'll look at fractions. I know that you have a very good knowledge, a very sound knowledge about HCF, about LCM and fractions. Today we will look at how fractions, how highest common factors and lowest common multiples are applied in algebra, okay? All right, so let's look at the objectives of today's class. Our learning objectives today will be that by the end of this lesson, you should be able to define algebra, okay? Find the highest common factor of algebraic expressions, then factorize algebraic expressions, find the lowest common multiple, that is the LCM of algebraic expressions, and of course add and subtract algebraic fractions. Okay, so those are the things we hope to achieve today. So let's start. Okay, so what is algebra? I know so many of you must have heard of this name in mathematics, algebra. Okay, so by way of definition, I said in simple terms, algebra is a branch of mathematics that deals with substitution of letters and symbols for numbers. Okay, it is that division of mathematics that deals with letters, symbols, figures that are not real numbers. Okay, any mathematical expression that you see, maybe the letters of your alphabet or any other symbol that is not our real normal numbers, okay? Those are called algebraic expressions, okay? So examples or illustrations of what algebra look like. When you open your mathematics text, you could see something like A. They'll ask you to add A. Sometimes they ask you to add A plus B, okay? Sometimes they'll ask you to do something like 6A plus 5X. Now, you will notice that these particular expressions we have here, they are different from our normal, we have 1 plus 2, just like what we have here. They are different from, let's say, this is 64 plus 53. Okay? Why these are our normal mathematical expressions using real numbers, algebra deals with using letters or symbol which mean a particular thing in mathematics. So like we said it is a branch of mathematics that deals with substitution of letters for real numbers. It means that this A we have here represents something. Do you understand me? The X we have here represents something. For example, if I say 2A is equal to 4. Look at this. 2A is equal to 4. It means that this means something. This A represents something. This A represents 2, and when you have a number with any letters attached with it, there is an invisible multiplication sign in between them. It means that here there is an invisible multiplication sign between 2 and A. So this means 2 times A equal to 4. That is what they are saying. That tells you that if 2 times A is equal to 4, it means that A is representing a number there, which if we solve, as we go ahead, if we solve, we will know that this A represents 2, because what can multiply 2 to get 4? It is only 2 that can multiply 2 to get 4. So it means that this A is equal to 2. So this is 2 times 2 is equal to 4. Do you understand? So by way of defining what algebra is, by this illustration and these examples, you will now understand what algebra is. So let's look at what we have here. Let's look at finding highest common factors of numbers using what? algebra. HCF of algebraic expression. So we are going to look at the first thing there. The first question there is number 1. So let's look at the solution of this problem. So now, just as the normal way we are asked to find HCF of real numbers, it is also possible they ask us to find HCF of algebraic expressions. Like this, these are algebraic expressions that we have here. These are algebraic expressions. So they're asking us to find the highest common factor. What that means is that these two expressions, 12ab squared and 30a squared b, these two expressions, it means they have common factors. Common factors. Now, the common factors we are talking about, they are not asking us to find the highest common factors. It means they have lowest common factors here and highest common factors. Okay, so we are going to get this solved. By so doing, we can get the highest common factor. So what you do, the way you solve your LCM or the way you solve your HCF questions using division method, division method is usually a very easy one of a very easy way of finding the HCF of numbers. So let's using division method to solve this. Okay, we ask ourselves, in these two expressions, we need to look for factors that are common to this point and to this point. Do you understand me? The factors we will use must be such that the factors must be common with this and with this. That is why it is called highest common factor, or that's why it is even called common factors. Don't mistake it for LCM. When people look for LCM and they try to compare it with HCF, in LCM, you don't need to have a factor for this and this. Once you have a factor for this, just keep dividing until you get to 1. And you do the same thing for the factor of the other number you want to divide until it gets to 1. That is for LCM. But for HCF, you get a common factor that must distribute to both expressions that you are given, or both numbers that you're given, or depending on the question, it may be 3 numbers, 4, 5, 6, or more. Okay? So here, if we look at this place, 1 is a factor of all numbers. 1 is a factor of all. So if we use 1 here, it will keep giving us 12ab squared, and we will keep giving this because 1 divide any number is that number. So let's leave 1. Let's go to another factor. Beginning, can you see that I began from the least factor? Always start from the least factor. You ask yourself here, which factor can be used that is common to this and this, the least of them? I think 2 is common to 12 and is also common to 30. I will advise you, as a beginner, we know that we have A here, we have B here, we have A here, we have B here. Okay? As a beginner, I will advise you, get the factors of the real numbers first. After that, we get the factors of the, what is it called? Of the alphabet. Do you get that now? So here, 2 is common here. 2 is also common here. So we take 2 out. 2 into 12ab squared will give us 6ab squared. How do I mean? 2 into 12 gives us 6. 2, okay, so gives us 2ab squared. Do you get that? 2 also, which is a common factor here, 2 into 30 is 15a squared b. Do you get that? All right. The next thing you ask yourself, do they still have common factor? If they have common factor still, keep dividing with that common factor until we get to a point where there is nothing common between the two expressions. Do you understand? So here, something is common between 6 and 15. Something is common. There is a number that can divide 6 and can also divide 15. I know as I'm talking, you are getting that number now. That number is number 3. Okay, so the number 3, we use number 3. Okay, 3 into 6 gives us what? 2. So 2ab squared. Then 3 into 15 gives us 5a squared b. Do you get that? Now, we look at again, we are still on the real numbers. We look at 2 and 5, which are also real numbers now. You ask yourself, do we have any number, or yes, any number that is common, that is a factor of 2 and 5? Do we have any factor of 2 and 5 that are common? Of course, we have factors of 2. 1 and 2, they are factors of 2. For 5, 1 and 5, they are factors of 5, but they are not common. Now, for 1, we don't use 1 as a common factor of order, because if we use 1 will keep giving us this number and will not arrive at any. So 1 is excluded. So here, the factor of 2 here is 2, and the factor of 5 here is 5. So because of that, because they don't have a common factor, we are done with anything real numbers. So we now face the, what is it called? The algebraic expressions given, like the letters given there. Now, if you look at the letters we have here, this is ab squared, and this is a squared b. So it means that for these two expressions, there are some things common to this place and to this place. The first thing that is common, we have a here, we have a here. Then another place we have b here and we have b here. So since we have a here and a here, remember, if we divide a by a to give us one, meaning a is a factor of a. Do you understand now? So what that means is we have a here, a into a can only go into a into a is, so we will not have a into a is 1. So this will be 2 times 1 times b squared. Okay, so this is 2 times 1 is still 2. So a cancels this, a cancels this a. This is what I mean. Do you get that now? So that we have 2b squared. Then here, this a again goes here and remove this a squared, means a times a. So one of these a's we remove 1a. So I'm removing this a, will go and remove one of these a's so that only one a will be left here. So here we'll have 5ab. Do we get that now? Okay, so look at the expression we have here. We have just 2 and 5 are not common. We have eliminated one of the a's, meaning there is no longer a here. The only thing common in the two expressions now is b, the terms of b. Do you understand that? So that also brings us to having b, removing one of these b, for there to be just 2b. Then here, this b also remove this b for us to have 5a. Now, at this point, we have 2b and 5a. There is nothing common apart from 1 between them. So because of that, we have arrived at getting our HCF for this expression. So we now we say therefore HCF of this expression, this, let me write it, 12ab squared and 30a squared b is equal to, you multiply all the factors you use to bring this in down to the point where they don't have common factors again. All these factors will be multiplied. The answer of that multiplication, that is their product, is the highest common factor. So this is 2 times 3, that is this 2 times this 3 times a times b. Do you understand that now? So this gives us equal to 2 times 3 is 6. And 2 times 3 is 6. 6 times a is 6a. 6a times b is 6ab. So our highest common factor of this expression and this expression is 6ab. That is how to get that particular answer. Okay? So let's take another example. Let's take another example. Solution. Okay. So let's look at that. So this means if we have this, it means that we bring our 18a square y and 27x square y square, and we look for the common factors. We look for the common factors that will give us what we are looking for. Is that okay now? So we have 18, we have a, we have y. Here we have 27, we have x, and we have y. So we have some expressions there that have common factors. For example, 18 and 27, they have common factors. Okay? So let's start with that. Now, if we look at 18 and 27, like I said, always start with numbers. 18 and 27, the common factor of 18 and 27. First of all, let's start with the factors of 18. 2 is a factor of 18. 3 is factor of 18. What is it called? 6 is a factor of 18. Do you get that? 9 is a factor of 18. And of course, 18 is a factor of itself. Okay? Now, if we look at 27, okay? Look at that 27. We have 2, which is a factor of 18 here, is not a factor of 27. So 3 is a factor of 27. Do you get that now? 9 is a factor of 27. And of course, 27 itself. So let's look at it and see what we'll get. So since 3 is a factor of 27, 3 is a factor of 27. What that means is that 3 is also a factor of 18. So 3 into 18, 3 into what? 18 gives us 6. Do you get that? 3 into 18 gives us what? 6. Now, 3 cannot go into all this, so we bring all this down. A square y. 3 is going again to 27. 3 into 27 gives us what? 9. Do you get that? 9 times 3 is 27. All right? So 3 into this will give us 9x squared y squared. Are you with me? Now, you ask again, between 6 and 9, do we have factors or a factor that is common between them? Yes. 3 is a factor of 6, is also a factor of 9. Do you get that now? So we go with 3 also. 3 into 6 gives us 2. So this is 2a squared y. And 3 into 9 gives us 3. So this is x squared and y squared. Do you get that? So for the real numbers now, 2 and 3, no common factor. So we are done with the numbers. We enter the letters now. Do you get the point now? So here we have a squared. And here there is no term as a. So it means that we don't have any business with a. There is no business we have with a. So a is there. A is only expressed in this particular expression. It's not expressed here. So we don't have any business with it. Now look at y. We have an expression of y in this other expression that we have here. We have a term of y there. What that means is that we can bring that y, since it's common here and common here. So y should come for us and do this for us. So this y removes this y to give us 2a squared. This y removes this y also to give us 3x squared y. Now, if you look at this now, we don't have any expression that is common in the two expressions. This is 2a squared, nothing there is nothing in 3x squared y that is common, that is relating to 2a squared. So because of that, we take our what? HCF from here. We say, therefore, HCF of 18a squared y and 27x squared y squared is equal to multiplication of the factors that contributed to giving us this, okay? 3 times 3 times y gives us 9y. So what that means is that the HCF of this expression is 9y. Just like the HCF of 18 and 27 is still 9. Do you understand me? Like I said, this is for division method. We can also use expanded method, multiplication method, to find these two things I have said now. We can use multiplication method to find the answer. Do you understand me? So let's see if we can use multiplication method. The first one we had there was what? 12 what? 12ab squared. So let's see what, by expansion, what it means. Okay? Then this one we have 30 what? A squared b. Okay? So by expansion, which I believe you probably know, we'll still come to that maybe sometime, but by expansion, what this means is that you expand, take the factors of 12, okay, express 12 in its factors, maybe in its prime factor or whichever one you want to use, maybe in its prime factors. So the prime factors of 12 is 2 times 2 times 3. These are prime factors of 12. 2 times 2 times 3 gives us 12. How? 2 times 2 is 4. 4 times 3 is 12. Okay? Then this AB square means times A, like I told you when I was defining what algebraic expression is. This 12a, there is an invisible multiplication sign there. There is also an invisible multiplication sign here. Then this b square also, there is an invisible multiplication sign inside of b, multiplying b by itself. Okay? So this is times a times b square means b times b. Okay? Why for 30, if we also express 30a squared b by their in expansion form, 30 will mean 2. Okay? If we say 2 times 3, because if we say 2 times 4, okay? If we say 2 times 4, 4 is not a factor of 30. So 2 times 3 gives us 6. Then 6 times 5 gives us 30 times a square means a times a, then times b. Okay? Now we have opened this in an expansion form. What we will now do is match the numbers you have here with the same numbers we have here. For example, we have 2 here, so match 2 with this one. We have 3 here, match 3 with this one. We have A here, match A with this one. Do we have B? Match B with this one. So here we are left with 2 and B. Now if we look at this place, there is no place to match 2 with here. There is no 2 here. Now we go to the other thing we have not matched. Which other thing is that? B. There is no other B here to match it with. Do you understand that now? So now to get the HCF of this, we take only those things that have been matched. Here, which number did we mark here? Did we match to each other? Is 2. So we don't bring the 2 here and 2 here, like 2 times 2. No. We bring only 1, 2 out. Okay? So we say the HCF of this, we now mean this is 2 here, right? This is a common factor. So we say HCF is equal to 2, these two, then another number that we combine together, that we merge together is 3. So we say times 3 times another expression or letter, whatever that we merge together is A. So times A, okay, times another number we merge together again that have common factors in the two is B. Do you get that now? So we say this is 6 times A, 6A times B is 6AB, which gives us the same thing as what we had here. Do you get the point now? So whichever method you want to use, the same thing you can apply in this particular one and you will get the same thing. Okay? So I think we should just proceed. You can use the same method. Maybe you try it on your own and get this 9y using this expanded form. Whichever one you want to use in your exam hall, no examiner will ask you to use this particular method. Whichever one is convenient for you, use it. For me, when I was in your age, I always use this method. It is faster and it is easier to go by. Okay? All right. Let's look at factorizing algebraic expressions. To factorize means to write an expression in the terms of its factor. That is what it means. Okay? Like, if I say you should factorize 9, Okay, so as I said, to factorize means to write an expression in terms of its factors. Okay? To write an expression in terms of its factor. For example, if I ask you between, let's say 4 plus 6, okay? And I ask you to write this expression in terms of what? Its factors. What I'm saying is that give us the factors of 4 and 6. And for you to write expressions like this in terms of its factors, it means that first of all, the expressions should have common factors. Now, if you look at 4 and 6, they have a common factor. And that common factor is what? 2. 2 is common in 4 and 6. It means that 2 can divide 4 without remainder and can also divide 6 without remainder. Do you understand that now? So what we do is to multiply this expression by what? 2 and divide each of the expression by 2. You multiply all of them by 2 and divide each of them by 2. So this thing will now mean that 2 is into 4 plus 6. This 4 is over 2. This 6 is over 2. Do you understand that now? What that will give us is 2 here is 1. 2 in 4 is 2. 2 here is 1. 2 in 6 is 3. So this will mean, just permit me to go into the other side of the board. This will now mean 2 is still outside of the bracket, but this is now 2 plus 3. Do you understand me now? So we have factorized this expression in terms of its what? Factor. Do you understand me? In terms of the factor of this 4 and 6. This is the factor. We have factorized it. Do you get the point now? So what that means is that if your factorization is correct, if you expound this, it should also give you what this is. If you expound this, 2 times 2 is what? 4 plus 2 times 3 is what? 6. So can you see that? So that is what we want to look at. We can also factorize algebraic expressions. So let's look at that quickly. Now I have here factorize the following. Number 1. So they say we should factorize those 2 expressions. Okay. So let's have them factorized here. So we have the first one is what? A. 12y plus 8z. They say we should factorize this. The rule is this. Look into the 2 expressions given. Do they have a common factor? Is there any number that can divide 12, especially the least common factor, the smallest common factor? Is there any common factor for 8 or for 12 and 8? Remember, this place is Y, this place is Z, so we don't have any business with the letters. The only place we have business is with the real numbers. Now, between 8 and 12, yes, we have 2 and what? 8. Now, if we have, sorry, we have 2. 2 is common here, is also common here. Is a factor here and here. Now, if we use 2, we will also have a factor that we need another factor of 2 to get. So when you know the least common factor that can go into the 2, okay, get another factor that once you use that factor, there is no other factor. Once you get the number, there is no other factor of that. For example, if we say 2, 12 over 2 is equal to 6, 8 over 2 is equal to 4. These things still have common factors. So we don't use 2. Do you understand me now? Now, if you look at again, which other factor is common to 8, to 12 and 8? 4 is common there. 4 is common to 12, is also common to what? 8. So if we do 12 over 4 is equal to 3, 8 over 4 is equal to 2. These two answers are not common. So we use 4 because it gives an answer that we don't have any common factor existing between them. I don't know if you get that now. All right, so the rule is with that factor, multiply the terms with the factor and also divide each of the terms by the factor also. So what that means is 4 is a factor here and here. So we bring 4 out, and 4 we go and multiply 12y plus 8z. Remember, 4 multiplies them. This same 4, which is their factors, we also divide them. Do you understand that now? Do you understand that? So what that means is 4 here is 1, 4 here is what? 3. 4 here is 1, 4 here is 2. So this means 4, open bracket, this is now 3y plus 2z. This is our answer. So this is, we have factorized 12y plus 8z to be what? 4, open bracket, 3y plus 8z. If we expand this bracket, we'll get 12y plus 8z. How? 4 times 3y is 12y. 4 times 2z is 8z. Okay? So we have done that. It's quite simple and very straightforward. Then the second one says that the second one says 24pqb 24pq minus 16p square minus 16p square. Okay, I know that reminds you of a musician in Nigeria, but that is not who we are talking about. So the same thing, look at these two expressions, 24 and 16, and look at P and P. It means that P here and here is first of all a factor. Do you understand that now? So what that means is that look at the factor of 24 and 16. What is that factor that can divide 24 and divide 16 such that their answers will no longer have any factor? Do you understand me now? Now, if we look at 2, 2 is a factor here, but if we do for 2, 2 will give us, here it will give us 12, it will give us 8, but they still have factors. If we look again, if we look at 4, what about 4? What about 4? 4 here, okay, will give us 8. 4 here will give us 4. They still have common factor. So what do we do? What about 8? If we check 8 here, 8 here will give us 3 because 8 into 24 gives us 3. 8 into 16 gives us 2. So 3 and 2 have no factor. Do you understand? So we will use 8 as the common factors. Do you understand me? So you must really have a very good understanding of your factors of a number. Remember, factors of a number is a number that, or they are numbers that can divide a particular number we are talking about without remainder. Do you understand me now? So 8 is a factor here. And remember, 8, P is also a factor here, a factor. They are common. So their common factor here is P. Do you understand me? So we are talking about 8P. 8 times P. So 8P by this method, multiply the terms with the factors. So the factors, common factors is 8P. 8P is their common factor. So that means 8P will multiply 24PQ minus 16P square all over 8P all over 8P. Don't forget that. Do you understand me now? All right. 8 into itself is 1. 8 into 24 is 3. P into itself is 1. P into P is 1. So 8 here is 1. 8 into 16 is 2. P into itself is 1. P into P square. We will remove one of the P to remain 1P. So at the end of the day, we are having 8P open bracket. What we have here now is 3 and this Q that we did not touch. So 3Q, you get that? Minus. Here we have 2. Then there is a P that is left here because we removed only one P. So that P is now 2P. Close your bracket. We have expressed that in terms of their factors. So this is what the answer is. If you expand this, it will give you 24PQ minus 16P square. Okay? All right. So let's see if we can get some stuff from our exam guide. In our exam guide, we have a question there. Good. So solution. We are asked to factorize 16y squared plus 28xy. Okay? So we are asked to factorize this. All right? So what this simply means is factor common to this place, to this and this. First of all, factors common to 16 and 28, and we have y here common. So first of all, we have y. Any factor we are talking about will be times y. Will be that factor and y. Okay, so 16. Okay, here we have 2, but it will give us a number that have. Okay, 2 here is 8. 2 here is 14. So 8 and 14, do they have a common factor? 8 and 14. Yes, 2 can still go there. So if we go 4, 4 here is 4. 4 into 28 will give us 7. Okay, so 4 is a factor here and here. Do you understand? So we are talking about 4p because 4y. Y is a factor here. Y is also a common. So we have common factor of y here and common factor of 4 here. Do you get the point now? Okay, so what that means is common factor is 4y. That is 4 times y. Do you get that? So what that means is 4y is into 16y squared divided by 4y, okay, plus 28xy all over 4y. You get that now? So 4 goes into itself is 1. 4 into 16 is 4. Okay? Y into itself is 1. Y into y squared will remove one of the y's there. Okay? Here, 4 into itself is 1. 4 into 28 will give us 7 because 7 times 4 is 28. Okay? Then here, y here goes into itself is 1. Y here is 1. So what do we have? Okay, so what we have here is now the expression of 4y open bracket. Now in the bracket, what we have in this bracket now is the answer we got when we divided 16 by 4. So this is 4. every other thing here, okay, 4 and y, because we remove one of the y here. So this is now 4y plus, here we have 7 and x, because the y was taken off by this y here. So this is 7x being our answer. And I think the option there is 4y. That is option B. Option B is correct. Option B is correct from this particular expression we took. Okay? All right. So we have another one here, 4x squared 16, 4x squared minus 16x. Let's take that one as the last thing we'll take for that. They say we should factorize 4x squared minus 16x. Okay, so our factors here, of course, our factor here is 4, because this will give us 4 into itself is 1, 4 into itself is, remember, the factor we use is a factor that when it divides this and this, it will give an answer that are not common. Do you understand? All right, so here, our common factor is s is here, so a factor of x is there, so it's 4x. Because 4x is here, 4x is here too, okay? So this will mean 4x into 4x squared over 4x minus 16x over 4x. You get that? So this will mean 4 into itself is 1, s cancel one of the x, so we have just one x there left. 4 here is 1, 4 here is 4. Okay, x cancels x divided x is 1. 1 divided by 1 is 1. Okay, so this is 4x into everything here now is x that is left. So into x, do you get that? Minus here, what we have left here is just 4, minus 4. Do you get the point? So this becomes our answer. And our option there is option D, 4x, open bracket, x minus 4. All right. So I think with that, we can wrap up with this. Maybe when we will have the part 2 of this particular topic, where we look at the lowest common multiples of algebraic expressions and solving algebraic expressions that have fractions in them. All right. Thank you very much.